All right, balancing equations video, here we go. Balancing chemical equations. You will do so many of these through high school, heck, through 8th grade, through high school, through college. It never stops. If you plan to major in chemistry or do anything science related at the collegiate level, you're never going to say goodbye to these. You're always going to do these. These are so important. If you're working in a lab and your boss or a coworker asks you to make something, make a brand new substance from something, like we're learning about chemical reactions, you've got to know how much, you've got to figure out the ratio. It's so important. This skill is so important to be able to master. Okay, so we're doing some easy ones for now, but they will get more challenging. And again, on the website, there's about 300 of these. Now, do I expect you to do all 300? I mean, I know some people would. I'm not going to say your name, but I know who you are. You're probably laughing right now. Or somebody that know who would do this. I can picture that person right now. He wears glasses. I'm not going to say his name. But, but again, the more you practice, the better you'll be, okay? This is counting atoms, but it's being able to balance, okay? So on your quiz, you're going to see about 8 to 10 of these. A little bit more challenging than these. But the more you practice, the better you'll be, okay? So please watch the step-by-step method in order to do these properly, okay? So in a chemical reaction, take a look at number 1 on the paper here. And again, you must follow the format I give you. You must take inventory. Again, that's the key word. Taking inventory is so important. Taking inventory is so important. So again, you will learn or have learned that the left side, this is a chemical reaction. Okay? But this format with these symbols is a shorthand way to write out a chemical reaction. It's called a chemical equation. And we'll learn that the left side of the arrow is called the reactants, the participants in a reaction. They yield or produce final products. So in this combined, it makes something brand new. This substance here, that's a chemical change, a chemical reaction. But here's the thing, you're going to learn something called the law of conservation of mass. Okay? The mass of the reactants must equal the mass of the products. So we have to count how many on each side we have. So step 1, watch this. We draw a line right below the yield arrow. Okay? Step 2, list the atoms you have. And here's the key thing, they must be in the same order. Watch. If I say NH over here, right? Please put it in the same order over here. Don't do H, N. It's confusing. Just keep it simple. N, H. Just like that. Now, count. Oh, counting atoms. Easy. Right now I have 2 nitrogen atoms. I've got 2 hydrogen atoms. I've got 1 nitrogen atom. Oops, all broke. 3 hydrogen atoms. Okay, so this equation is not balanced because I've got 2 nitrogen on this side, 1 over here, 2 here, 3 here. Okay, so let's take a look. What can we do? You cannot add a subscript. You can only add a coefficient. Okay? You cannot add subscripts. You can only add a coefficient. Now, I'm going to sing a song about this on Wednesday. Ask me to sing it, okay? And when you watch this again after Wednesday as a review, I want you to stop for a minute and sing this song. But I'm not going to sing it on video because I don't want to give all my secrets away to other schools. It's just, we'll talk about it in class, okay? But you can't add a subscript, you can only add a coefficient. We'll talk about that on Wednesday. It's a good song, okay? So, what do we do here? Okay. It says here I've got 1 nitrogen over, I need to get 2. And here I've got 2 hydrogens, I need to get 3. Okay, well, let's take a look here. Why don't I start by making this 2? Well, how do I do that? I can't do this. You can't add a subscript. Illegal. You can only add a big bad coefficient. So now you got to count again. Watch this. 2 times 1 is 2. Uh-oh. Oh no. But 2 times 3 is 6! Oh my gosh! I messed it up! Wait a minute. What do you know about 2 and 3? They really don't go together. What do 2 and 6 have in common? That's the key word. What do they have in common? Well, let's take a look. So now the nitrogen is balanced. But now I gotta balance the hydrogen. You can only add a coefficient. You cannot add a subscript. So what do we do here? Oh, wait a second. I put, what times 2 gives you 6? Oh yeah! 3! And wait a second. 3 times 2 is 6. 2 times 1 is 2. 2 times 3 is 6. Yes, I did it! I did it! It's balanced. You can't add a subscript. You can only add a coefficient. Okay? Keep that in mind. The coefficient affects everything in that compound. There's your answer. Blank. No coefficient here. 3, 2. See how nice that looks? Okay, that's the first one. Let's do the second one. Isn't this fun? You know what the funny part is? Some of you are going to love doing this. Some of you aren't going to like it, but KClO3. Sorry, that should be a subscript. Okay, let's take inventory. I've got K, which is potassium. I've got Cl, upper, lower, upper, lower. I've got oxygen. Now please, please write in the same order on the other side. I don't care how they appear, please. KClO, KClO, it just keeps you organized. Now do an initial count. I've got 1 potassium, 1 chlorine, 3 oxygens. See that? 3 oxygens, 1, 1. Over here, 1 potassium, 1 chlorine, 2 oxygens. Okay, everything's balanced. Oh, this darn oxygen! I have to balance that? Oh man. Okay, so let's take a look. And in case this ain't showing up, 3 oxygen, 2 oxygen. 3 on the reactant side, 2 on the product side. Okay, so how do we balance it? Where to begin? Where should I start? Well, why don't we make this divisible, where they have something in common? This is a 2 and 3 relationship. Why don't we get this to 6 and see if that makes things easier? So watch this. How can I get this to 6? Add a 2. But wait a second, then everything else is going to be out of whack. It's trial and error, people. Watch. 2 times, coefficient affects everything. 2 times 1 is 2. See how that works? 2 times, oh. 2 times 1 is 2. 2 times 3 is 6. Parcia, what's the matter with you? Now everything's out of whack. Chill. We got this. Chill. Calm down. Now, this is really important. I want to do this. I'm going to put this in reds because this is a problem. A lot of kids screw up. Obviously, we need to get this to 2. So you add a coefficient. 2 times 1 is 2. 2 times 1 is 2. Now remember I said the coefficient affects everything? This coefficient, and notice how serious I am right now, this is really important. This coefficient only affects the compound. It does not affect anything past the plus sign. It does not affect this. It affects something here, 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 here. Not there. Okay, everyone screws this up at first. Please be careful of that. It only affects the compound it's next to. Please keep that in mind. Please. So it's 2 and 2. Oxygen is still at 2. It's not 4. It's not 4. It only affects the compound. Please, please, I get that question every year. And that's fine, I understand. Please don't mess that up. So everything's balanced except the oxygens. I have 6 over here. Well, how do I get this to 6? Oh, very simple. Put a 3 there. You see that 3? And this becomes 6. And we have a balanced chemical equation. Take a look at that. Let me see the camera, how it looks. Let's see how it looks. Can we see everything? Yes, I can see it all. That's awesome. All right, I'm getting better at this, I think. Okay, see how that works? Please keep in mind the coefficient right here. It only affects this. It doesn't go past the plus sign, okay? Please keep in mind of that, okay? And I'll do the third one, then you're going to do the remainder on your own. Okay? Here we go. Next one. Our reactants are sodium chloride, NaCl, plus fluorine, yields sodium fluoride plus fluorine gas. Okay, take inventory. Draw a line down the middle. I've got sodium, I've got chlorine, I've got fluorine. Ooh, it rhymes. 2 halogens and an alkali metal. What are you talking about, Mr. Parcia? What is a halogen? What is an alkali metal? Trust me, in May, piece of cake. You'll know all this stuff. Again, same order. Whatever you have over on this side, you got to have in some form over here. NaClF. Keep the same order, okay? Please, keep you organized. Now count. 1 Na, 1 sodium, 1 chlorine, 2 fluorines. Over here, 1 sodium, 1 fluorine, 2 chlorines. Oh man, I gotta balance this thing again? Jeez. Okay, here we go. Let's take a look. What can we balance first? Okay. Why don't we, well look at this. This isn't balanced with that, so why don't we just start off right. Let's add a 2 here. You cannot add a coefficient in the middle of a compound. You see that right there? That is illegal. The coefficient can only go at the beginning, and you cannot add a subscript. Don't you dare ever do that. What is that? I don't even know what that is. Doesn't make sense. Has to be at the beginning, okay? Been doing this for years. I've been doing this for years. I know what you guys do. Put the coefficient out here. 2. 2 Na. 2 times 1. 2. Okay, you with me so far? So now I got 2 chlorines here. And 2 chlorines there. 2 sodiums, 1 sodium, 2F, 1F. What do I do now? Let's look over here. Oh, wait a second. Let's put a coefficient. You can't be here. You can't add a subscript. It has to go right here. Now, wait a second. I'm going to put that in red again. Because it only affects this. It doesn't affect that. This coefficient only affects this, not that. Please, don't forget that. This becomes 2. This becomes 2. Look at that. Perfect! It's balanced. They're not all going to be that easy. It's trial and error. So let's check. 2, 2. Well, does this affect that? Do I have 4? No. This only affects right here, not here. 2. See, that's 2. Here, 2, 2, 2. This only affects in here. Okay? So the next 3, you're to do on your own. And you know what? I will let you. We'll do the. I'll give you the solutions in class on Wednesday. Okay? We'll just talk about them in class. I'd rather take a couple minutes and talk about it in class to make sure you're okay. Check the website. There's a virtual equation balancer. You can copy and paste the equation and put it right in, and it'll balance it for you. Now you can do that and get them all done, but I would do it if you're stuck or to check. It's your choice. If you want to be an A student, you'll practice a lot, try your best, make mistakes, it's okay, and then check it. Don't just use that to give you the answers, okay? I'm going to get you on the quiz, okay? I don't care how many you do correctly on your own. You just get the job done. Do whatever it takes to get an A, okay? Work hard. Have fun with these practicing. And I will spend a little bit of time in class on these to help you out, okay? So this will be quizzed on Monday. You'll have 8 equations to balance of differing levels, of different difficulties, okay? The more you practice, the better it'll be. Dude, have a study party, a balancing equations party with your friends over the weekend. I don't care. Go to Wegmans, have a little study group, right? Balance equations, make a game out of it, have fun with it. Let's make this go viral, okay? Let's call this the balancing equation weekend in Collegeville, Limerick, and Springford area. Have fun with it. Okay? All right. Get her done. We'll talk about this a little bit more on Wednesday. Thank you. Hope you enjoyed this video. We're on a roll. Yeah! All right. Bye. Good job.